Welcome back to Incremental, the continuous improvement podcast, our practice edition for the week. I'm Devin Bedoni.
And I'm Uriel Eisen.
We're going to be diving into some real down and dirty shop floor things that we did or talking about doing in this last week. And we got a quote.
Quote for the episode, the most expensive thing all of us are paying for is the information that we don't know. Unknown source. I really liked this because, well, I think it's a human psychology thing mostly where we don't like to lose things more than we like to gain things, which is sort of funny, which is irrational. Like if I'm like, hey, what will you do to make $100? You'll be less motivated than like, hey, what will you do to not lose $100?
Yeah.
So it's sort of maybe just exploiting that a little bit.
I was thinking about that yesterday. I don't remember what it was about, but just about kind of like the general bootstrap mentality and how far we'll go to not spend money on something. When often it's like you're actually losing money, probably.
Right.
Trying not to spend money.
Yeah, totally.
It's pretty funny.
But like part of that, someone was sort of talking about like, how, the cost of, let's say whatever you make now, let's say someone is making $100,000 and you ask them like, why aren't you making $1 million? Then in a funny way, their cost for the information that they don't know on how to make $1 million is costing them $900,000 a year. Right. Yeah, but it's kind of interesting, right? It's like, that's a kind of a good point.
Yeah.
It's like, what would I need to get in place? I think similarly in the shop, it's sort of like there's a huge cost to not making improvements. There's a huge cost to not knowing what to improve. There's like, and they are real costs. And I think it's sort of fine. It can feel like, okay, well, we are running a business, which is 100% true, right? Yeah. Like a lot of people, if you ask like founders of companies kind of, what would you do differently if you're doing it all again or something like that? It's sort of like, okay, if I was doing this, like knowing what I know now, I'd never would have started the company, right? So like there's a balance, but
yeah, I think also it can be like the things that we don't know feel very theoretical because we don't know them. And so the costs seem theoretical.
Yeah.
But the costs are real.
Right.
The answers are theoretical because they don't exist yet.
Yeah.
Ouch.
Yeah.
Ouch,
yeah. Anyway.
Ouch again. Well, we had a decent week for improvements. Nothing super major, but one small thing is I finally bought some of that Octane workholding T-slot cover. Yeah. It's not cheap, but it's really good. It's great. So we have one machine that pretty much always has a trunnion on it. Okay. With a tail support. So two of the T-slots are blocked at either end of the machine. Oh. And so the middle just clogs like crazy. And it's a task to clean out, or we just stop cleaning it out when things are really busy. So that's the first machine we put it on. And it's great. Just like quick spray down, like just way less chips, kind of surprisingly kind of everywhere. Like I think because they don't nest at the bottom, they don't build up above sort of, and everything kind of flows away better.
I definitely noticed that the second like one chip hangs up on something, it just like attracts this huge bunch of
Yeah. And so I remember a while back I had talked about that kind of hang up around softjaws and optimizing around the Carve Smart pattern. We had material. The R450 finally became available in the last couple weeks, and I could see that we were going to need to do work on it. It's sort of optimized for these 0.96 millimeter pull stud vices, and so I was like, well, first thing we're going to do is make some soft jaws for those vices. So we finally did for our Shunk KSC manual centering vices. Okay. Made a whole batch, and they're great. So we finally did it.
That's awesome. Nice.
And I think we're actually going to use, so we made like one of our job travelers for the job board for them. And I think we're going to use that as the Kanban for the jaws so that when we run out, it just goes back onto the production
like
board.
Physically, that same document will live on the tray of softjaws.
Yeah.
Very cool.
And then when we get to a low trigger point, we'll just put it up onto the production board.
Okay.
So feeling pretty good about that. We had a good long discussion about QC.
Cool.
We made a bunch of scrap without realizing it.
Oh, damn.
One of our people was gone for most of the week. While they were gone, discovered that a job that they had set up and run that still had a final op to do had been not done totally properly. So it was like not expensive parts, but like 500 parts that we had to redo.
Damn.
And no blame placed anywhere except on me, probably, for not setting good priorities in the shop, or not setting setting appropriate checks for, it's a repeat job. I think it's just like it kind of always runs good. It was very easy to just be like, it just runs. So we had a good talk about that, about just general priority shifting, and then also how we're going to handle QC for our constantly varying workflow and type. And the first step is that we just made a dedicated tray on our tray racks at each machine station with a tag that says QC. And when parts come off the machine, they go onto that tray and they can't go onto a final tray.
I love it.
Until some quantity that we decide on has been checked. And even if that's not a standard number, or even if we don't pick a number,
it like forces the conversation.
It forces the conversation, and it forces you to at least check one. Or some number.
Right.
So that was our first, after our discussion last week of making it part of the production process, that was our first step.
That's awesome.
Having an intermediate place that parts have to go to before they can go to their final place.
Right.
That is discrete and established that's what happens.
I feel like that's going to be such a load off for everyone, knowing that it's handled in a funny way.
Mm-hmm.
It's like not something you have to track anymore. Sure, maybe you have to go like have a conversation about what quantity do we have to QC, but it's not like going to get forgotten.
Yeah, what quantity and like what features. There's still a lot of little stuff. We discussed having kind of like our scaled like QC level thing as well. This was one of those, going back to our whip board discussions, this was one of those things where we had it up there. We're like, okay, we have this enough for now. We're going to circle back to it, but cross it off for the moment.
Gotcha.
So I think that was pretty cool.
That's very cool. 2 comments, I guess. One, jumping back to your Octane workholding T-slot covers.
Yeah.
I think people not underestimate. I think that's very cool that you did that, because it's very easy to like keep sweeping a shop and never go like, where is this dust coming from? And actually go to the source of the dirt of the problem and fix it. And a huge amount of time is eaten up in shops dealing with recurring stuff that no one ever just chases down.
Yeah.
Similarly, on the QC, I think from a sort of a theory standpoint, like in-station quality is a huge emphasis into the production system, and not letting parts pass. And so I think, it's just such an essential, like they emphasize it for a reason, I guess.
Yeah.
In terms of rework, in terms of all that stuff. So
that was kind of the discussion we had, was just like, I am guilty, definitely, of emphasizing speed and production and throughput. And I think that has carried through to anybody who's trained under me. It's like, it's important to keep things going and keep things running. Right. And I think both of the folks who work for me have really like impressive hustle, which at times can be a detriment when they're like, okay, I'm in the groove, keeping things going, hit go. And it's like, yes. And if we're just making scrap, that's not good. So we have to figure out how to temper.
It's worse than idle.
It's worse than idle. We have to figure out how to temper that hustle
tricky.
Just slightly, just enough to make sure that things are.
It's funny. I feel like I'm suffering on the other end of things where I am no one hustles because I'm very much like, it is very important that we do the checks and make sure everything is right. And that, I mean, for me personally, I hustle, but after reading these books, I've been like really trying to not and sometimes I sit there wondering like, how do I get people to maybe just put a little and like walking across the shop is, you're not going to mess that up. I mean, sure. Yeah. If you start running, then yeah, that's dangerous. But yeah. So
that's funny. Yes. I'm
hit that sweet spot.
Yeah. It is an interesting sweet spot to try and hit.
Yeah.
I mean, we'll see what happens. That just reminded me, looping back to our coolant flow changes, like the washdown changes that we made in the machine. We had one pretty severe failure where, so the big hoses at the front, somebody had aimed them more rearward, and we did there's that warning on the front of our machines. Maybe not on yours, because I think yours is fixed for the y-axis way cover on the front. On mine, there's a warning like, don't let chips build up here or it'll pinch.
Oh, yikes.
So we had that happen, and it bent the hell out of the front way cover. It's still totally functional, but that was like
damn,
why is this machine alarmed?
Yikes.
And it was, just like a huge,
like it alarmed out the servo.
Yeah.
Wow.
Yeah. And the sheet metal on those is not actually very thin on the way covers.
Yeah.
It's pretty substantial. I've tried to bend it back once. It's hard to bend, and it bent. So
interesting.
Be careful what you do if you're messing with that. The machine's fine. Everything's fine.
Yeah.
But it's just one of those things where it's like, oh, we have to pay attention to how we aim this. Overall, that change I think has been pretty good. We're getting like a little bit of a collection with most parts that we're running right at the front.
Okay.
But less overall damming around the chutes. So I think our overall flow is much better of chips out of the machine. Yeah.
That's cool.
Yeah.
Yeah, you can't have I don't know. I was just thinking about this a lot. It's easy to say like, don't change things after something like that, right?
Mm-hmm.
Instead of seeing it as like the cost of improvement, sort of like that small failure of bending a way cover, even if you went and bought a new one, over time, like the cash savings you're going to have from saved time on cleaning out those machines is going to like massively outweigh that cash.
I think so. One would hope.
Yeah, one would hope. Well, I even zooming out a little further, as an organization, your overall improvement efforts will be, and like building a culture of continuous improvement and encouraging people to think and experiment and try things. Mm-hmm. The savings you'll get from that will outweigh the cost of that way cover.
Yeah, absolutely. Absolutely.
I suppose you could do something substantial enough where that would not be the case, but hopefully that doesn't happen.
The thing is, those things happen anyway.
That's true. Yeah. I mean, we almost had an electrical fire in our shop, not due to us in any way. Mm-hmm. Someone wired, I think we talked about this, but if the shop burned down because we made some weird improvement, that would probably...
If the shop burned down?
Yeah, like there could be...
Sure. That's a pretty catastrophic.
Yeah.
I guess I'm just saying like small issues like bent weight covers and stuff. Like, I don't know. I think those of us who have kind of started our own shops, I think often actually have like a pretty low failure rate because we're so attentive and so like attuned to the costs. And my impression is in some of these larger production facilities, like significant issues happen not irregularly. I don't know. I could be wrong. I haven't spent much time in them, but I think when you get a lot of people running machines or in production processes who are not super invested in the process, like things happen. So I think whether you're improving or not, like things are going to go wrong. And as Goldrat says, Murphy will strike. So anyhow.
Fair. Yeah. Let's see. So Got a sewing jig Rev 2 going.
So this is of the quick change jig for the...
Not yet.
Gotcha.
We're scheming on that front. This is a job for a company in Europe, and they wanted an extra element. I think I talked about this.
Yeah. Weren't you making it so it was swappable, though?
It is currently swappable. I want to remake all the fixturing on that sewing machine. This just goes on the old fixturing. It's sort of like a layer on top of. And it's working great. Yeah, really no complaints. Pretty good. So that's going to we're now probably going to push that to the rest of our sewing tasks. Like just our standard straps, I think we're going to switch over to doing in jigs, which will allow us to probably have better consistency, less rework. It may slow us down slightly in the short term until we get that fixturing done. I was sort of wondering if I could make like an automatic feeder for the sewing machine, so a person could be loading the jigs and stack them on in a queue, and the sewing machine could kind of grab them from the queue. That's probably pretty
sounds challenging.
Yeah. Not anytime soon. But anyway, so that's good.
Does this mean you're going to also start adding like a extra element to your own for branding purposes and stuff?
Possibly. It could happen. I don't know. It is a lot of extra fiddling, I will say. So I'm not sure. I think like we had the conversation about whether to add engraving to the product versus like doing on the CNC versus doing laser etching after coating. And I think similarly, like you were sort of like, probably just do it on the CNC. It's going to be a few seconds and you don't add the handling. So I think you're probably right about that. So I think I'd rather push that to the CNC. Anyway, so we updated that, just fixing, a few like real world kind of issues we saw with Rev 1. A lot of the guides weren't quite tall enough. The slop was too much or too little, the little things of like, if we just tightened this up a little, it would push that into place. So that was nice. Definitely encourage people to, iterate.
So on your standard stuff, wanting to switch over, how often do you have to rework straps? Is it a common thing?
No. When someone starts sewing, that's the problem. That's the thing I don't like right now, is that if we got a huge order, growing that labor force would be really hard for me because it takes someone quite a few, I would say like 3 weeks easily before there's very rare rework. Like I'll still mess up a strap, but it's very rare. But so I would rather have, like, I think that now puts it in the category of flex work, where I could have a list of people around who are happy to work, a couple days here and there, or like a week here and there. And that puts it solidly in that realm. And looking at some of these larger orders that I've been talking about, like that will quickly become a big bottleneck. The sewing. And so having that sort of in the wings of something we can lean on, of like load fixtures and like here's how to run the sewing machine. It's hard to mess up, instead of like why don't you come practice for a few hours so that you are ready. So that's one. I went to change the cartridges on my respirator for paint. The date on, I always date them when I put them on so that you can kind of track how frequently they're getting changed. And so then I went to change it. It triggered a Kanban, and it sort of brought up the idea of like, how do you schedule maintenance in the shop? Which we still don't have a good solution for. And then it occurred to me that you can subscribe to things now on like Amazon and other platforms. And I was like, wait, what if that's the trigger to make the change? And so then I just scheduled it.
Since
so every
it's scheduled
time
anyway,
one shows up, you change them, which I thought could be useful for other things. Now, if that system breaks, how do you find that issue? I don't know.
If it just stops arriving?
Yeah, for whatever reason, like maybe it still makes sense to put an installation date so that at any time anyone can check it.
Yeah, certainly.
Right. So there's some thinking to be done there for sure still, but I don't know, never occurred to me. And now I'm kind of like, what else can I do with this? So that was interesting. Something I don't know enough about. How do you deal with lost, and maybe this belongs in our theory episode, but we lost a Kanban card a little while ago. And I know I've read about this in books of like that being a huge Achilles heel of Kanban because it is the presence of the card that you're always looking for. And if it's gone, it means it's triggered typically. Right. So it's not like a red flag that it's gone.
Right.
Which then leads to the question. Yeah. So ours like dropped behind a table and then we're like, we're out of these. Where is the card?
Yeah.
Because every time we sort of assumed Ed just was in the paint department or was, you know, working its way through the system, but turns out it was not. It was hiding. So
I don't want to go through production.
yeah just fell behind. So
don't send me away.
Yeah. So anyway, if anyone has any like practical tips on that, I'd really appreciate it if you wrote in.
You could have duplicates and you could have a master where anytime one goes to trigger, a master goes into like, this is in production.
Oh, interesting.
And then
or just at least like this has been triggered, because then you could see like
kind of same.
Yeah I guess if it got triggered successfully, went upstream but then got lost on one of the steps coming back. I don't know.
At least you'd know where to look.
At least potentially. It's something. I know this is something people have experimented with, and maybe it's just like sometimes it happens and the overall savings is better than, because this is the first time it's happened to us. So.
Yeah, maybe that's why they're like so emphasized that nothing travels without a Kanban.
That's true. That said, we didn't break that rule because nothing traveled. I can tell you that.
There was just 2 empty bins, basically.
Like at our assembly station, typically there's a bin with parts in front of it, then a card, then parts behind it.
Single bin.
Okay. Oh, that's a good point. So if it was 2 discrete bins, you should never have 2 bins without a card. Because I guess that's what happened, is the card fell out before we were finished with the parts in front of the card. But then visually it's not apparent. Interesting. So that's a good idea, is just having 2 bins. At least tells you it left before it should have, so maybe it fell. I don't know.
Or if you have a 2-bin system, it should travel with the bin, right?
True. We are not doing that.
Yeah.
Because the bins through our process aren't consistent, which is a separate waste. Like we use stainless steel baskets that go through our degreasing process and then into the oven.
Right.
And then it goes into the sandblaster, which is a separate container. And then it comes out and goes back in a stainless basket for another oven.
You could at least do a 2-bin system between paint and assembly.
That is true. That's a good call. Interesting. I'll have to look at that.
I don't know. We don't. I mean, 2 bins in small shops can start to get really annoying.
Yeah, but also, if anyone has any tips on lost Kanban,
totally,
let me know. I ordered sewing machine programming software. So that is
like CAM kind of, but for sewing machines.
Yeah.
Because how is it done at the machine?
You can't do it at this machine. So this machine costs like $7,000.
Yeah.
The one that you can program at the machine costs $15,000.
So how have you programmed in the past?
It comes with standard programs.
Oh, okay.
And then those are like most of what people use. And then if you want something custom, you traditionally would ask someone to make you fixturing and a program, and they'd send you all of that.
Gotcha.
We are making our own fixturing now. The next step is, I think I mentioned this, like waiting for the sewing machine to finish is waste. And so I think the double tack, like it sewing both bar tacks in one setup, will be a huge benefit because it will buy back all of the time you're standing there waiting for the sewing machine. And then we can slow down the sewing machine to match the assembly process, which means we'll have less wear on the sewing machine.
So double tack being right now, you place it, you hit go, you wait for it to finish, then you move it and you hit go again.
Exactly. Right. Yeah.
So it'll go and then it'll go.
Yeah.
Every time you hit the pedal.
Yeah. In the right place, and the fixturing will remain the same.
Yeah.
And so that was It was $650, so it's like not nothing. Really? And it looks like a word editor out of like, it's like so archaic. And I just feel like companies need to change and they are, but some companies are still not. They send you a CD, literally a CD. I was like, can you send me a thumb drive? He's like, no, we can send you a CD. So I need to figure out.
We have you over a barrel. I'm sorry, but this is how we do it.
So they send you that. You install it on your computer. It gives you a number, which I then call the dealer or email them number. They contact the manufacturer of the sewing machine, who sends them a password, which they then send to me.
Whoa.
And then it runs on one computer. I was like, what if I want to uninstall it and move it to a different computer? He's like, sometimes they'll give us another key, but sometimes you just have to buy the program again.
Oh my God.
And I was like, what if the computer dies? He's like, yeah, again, sometimes they'll send you a new key. Sometimes you just have to buy the program again.
Holy crap.
And I'm like, what % of their annual revenue is this crappy software, considering that most of their sewing machines you can, like, not most of them, but a lot of their sewing machines you can program out the machine anyway. It's like, just give this to me for free. Like, what is the problem?
You have just lowered the chance that I will be a repeat customer, whereas if it was the other way around, you're more likely to.
And because it's not free, there's not much of a community online on how to use it. So I called the dealer and I was like, hey, can I like come down there and you guys can show me how to do it? He's like, well, it's mostly just self-taught. He's like, just you'll but like,
wait, you didn't hear my question.
No, I get that. Can you then show me? Like, I don't know. We've been talking about this around robotic arms. There's a lot of companies that make robotic arms. As far as I can tell, they're all damn good. Right? I mean, yes, there's exceptions to that, but for the most part, they're all very capable machines. Some of them publish their how-to videos for free on the internet. Epson. Some of them want you to come in for a 3 to 5 day training that costs like $3,000. And it's like, I'm not against coming to do that, but at least get me running. Like, and then there's other companies which are so popular, and Haas comes to mind for this. Like, I almost bought a Haas, not because of the machine, but purely because of the community. There's so much out there. Like, I know that I can watch a video on how to do most basic things and a lot of the less basic things. And I just think, like, a lot of these companies don't realize what a benefit that is.
Apparently, or they're in some strange... It seems like they just haven't realized that that's a marketing tool.
I think that it's a marketing tool. Right. I think historically, you're not selling a ton of robotic arms to like some random dude in their garage. Now that's happening. And I think the companies that make that jump successfully are going to be because the other piece is like...
But even if it's not random guys in their garage, like engineers still need training. And it's not necessarily efficient to pay somebody to fly to another place to do a 3-day training. Like, and everyone would benefit. Not just
and
us.
I think it's a long game, and maybe this is why people aren't doing it. But like a lot of software companies that take over a particular industry, like Fusion, put a big emphasis on like who's the next generation of people who are going to be doing this thing, and how do we make sure they're on our platform? Right. You look at like. Adobe has done an excellent job of making all of their software sort of the standard at universities. Then you graduate and you go into the labor force, and it's like, well, I have tons of hours on this software. I'm just going to keep using that software. And sort of like...
Same with Haas. Like any manufacturing program at this point, seems like, not any, but...
A lot in the U.S.
If you go to a high school that has a manufacturing thing and they have a machining program, chances are very high that it's going to be
and then those people go into industry, and then someone asks them like, hey, we need more CNCs, what do you think we should get? It's like, well, I know Haas and it works, and I know the control, and anyway, I'm not saying that would make a big impact on their future business, but I am saying if it's a tiny % of your revenue anyway, what are you worried about? Like, there's no way this is a meaningful portion of their revenue.
Cost accounting issue.
It's just ridiculous.
Someone trying to lower the per unit cost on that. Interesting. we had a couple other things. We had this has not happened really before, but we had 2 complaints in 1 week from our anodizers of our parts having coolant on them. And we don't typically wash all of our parts. We typically do a very thorough air blast and then put them on a tray, and they, more or less dry. So I'm not exactly sure what happened with these parts.
Interesting. Do you think you're getting faster at turning things around so they have less time to just like evaporate?
Maybe, or these were also like large quantities, so maybe they got stacked and stuff built up between them.
Yeah.
I'm not sure really, but it seemed like something we need to tackle regardless of like trying to get cleaner parts out the door. So we actually didn't do it yet because it was a busy week, but the plan is make rinse buckets at each machine. So just like right at the door where you can just like dip and just dip it in some water.
Oh, cool.
And then the thought is that will become the makeup water for the machine.
Nice.
So beginning of each week, swap it out to make sure it's clean. That goes into the machine as the makeup water. You're retaining some coolant. Hopefully not wasting as much stuff.
That's clever.
And,
yeah.
And hopefully clean parts.
Do you only top off your machines once a week?
No.
Okay.
Okay.
Not once I was like, am I doing something wrong?
It'll be whenever you make up water.
Because I feel like
it'll be every day. Actually.
Almost daily. Okay. Especially in the warmer weather.
Yeah.
Cool.
It'll be very often.
It's like, do I have a leak? What's happening? Okay.
No, it's pretty much, well, sometimes it's multiple times a day, honestly.
Okay.
Depending on the parts. But, so I thought, I don't know how we're going to deal with all the dripping, but there's already some dripping. So
we found an air blast to be hugely useful.
Maybe we'll have to
What about a foot actuated air knife?
Oh, at the bucket?
Just blast air into the bucket. No, but we should talk. We should build one system that works for you, works for us.
Because I think like we'll air blast in the machine and then dunk, and then it's going to be covered in water.
Yeah.
So I think that we'll need a second air blast basically.
Totally. Yep.
An air knife might be nice and easy. Mm-hmm. If there was just like, we could just use a bucket lid and make a little thing that comes above it so that it's like,
sits on a bucket.
Just sits on a bucket.
That's a nice idea.
And then it would be modular, not like built into a bucket.
Right.
I don't know. We'll have to look. I've never actually looked at purchasing an air knife.
They're very expensive. I'm thinking of 3D printing one.
Yeah.
Because
it doesn't have to be amazing. It just has to.
No, that said, I do understand that there's like some know-how
to making an air knife work.
To making it efficient.
Oh, just not using a ton of air.
That said, and air does cost money.
It does cost money.
I don't know, but I don't know if I want to drop $350.
Yeah.
Maybe I will eventually. Maybe we'll 3D print one and then go like.
The simplest thing might be just like 4 like lock line tubes with like the smallest opening at the tip, and you could have like kind of like octopus arms that reached in, so it'll push down, and you put your part in the middle between where all the 4 nozzles came out, or however many nozzles.
I like that.
Going down, and that could blow into the bucket.
There's something here.
For this week, we're just going to cut some holes in some lids and just dunk. But I want to approach.
What's the hole in the lid for?
Oh, so we have a lot of our coolant buckets.
Yeah.
I'm not sure if this is all coolant buckets.
Opening them is impossible.
It is nearly impossible.
So here's how you do it. Yeah, it's a huge pain in the ass. Do you have, I don't know if you have one. You can either cut around the lid with like.
I've done that and still.
Oh, so I cut like 8 slots around the lid with the tool that you get from like for cutting rapid pipe is the one I use.
Okay.
It's literally a blade on one side. It's like sort of like cable shears or something.
Uh-huh.
And then that really easily cuts slits in the lid, and then it pops off.
Interesting.
I mean, not pops off. Pop is not the word I'd use. Yeah, they're very difficult to get.
I've seen some people want to like nearly run out of the building screaming, trying to get one off.
Yeah.
So what we've ended up doing is just cutting holes because it's
that works
way faster.
Interesting. Yeah.
Nice. Obviously, you can't close it again, but yeah.
Yep.
Anyhow, and then last but not least, we made our fourth axis on our R450, when it came, we had to get that machine into production, doing manually loaded 3-axis work.
Yep.
It's relatively small envelope. We had to get the fourth off the table as much as possible to make room, but we didn't have time to make the actual riser plate.
Yep.
So I just made some like aluminum little extensions to get it into position. And finally we had some time. So I actually cut that.
Nice.
The actual riser plate this last week, and we got it mounted up. And
very cool.
So now we can start doing fourth axis work on that machine.
Oh, gotcha.
Which we couldn't really before.
Yeah. Nice.
There's now the additional issue of we're going to be short on like fourth axis fixturing. So this is going to be forcing my hand to actually build the trunnions I've been thinking about, and get the shunk automatic vices all set up and the valving. It's
well, that'll be awesome once it's done.
It'll be a good thing once it's done.
Yeah.
Yeah. I'm kind of wondering if my initial thought had been tray on one pallet, trunnion with 2 vices on the other pallet for the spindle gripper automation.
Okay. Yeah.
And I'm kind of wondering if for the moment I'll put a single shunk vice on the trunnion and a single shunk vice, just 3-axis on the other table, and just do like really fast manual loading.
That will be an amazing machine to run.
It would be really great.
I've run the pneumatic vices manually.
Oh, they're fantastic.
They're amazing. I really think people should buy more pneumatic vices when not exploring automation.
Yeah.
Because I just feel like the payback on that is so short.
Yeah.
I wonder how you deal with safety of like getting your fingers in them if they're manually loaded. I mean, I've never been concerned about it, but I guess theoretically that would crush your finger.
When we've
more
done
than
it,
theoretically.
yeah, more than in theory. When we've done it, I've always just done an M code at the beginning of the program to start it.
To close the vice?
Yeah, sorry, to close it.
Okay,
with a delay.
Oh, nice. So you just close the door.
Yeah, you just drop the part in, close the door.
Yeah.
And
I've done that as well. You don't have seating force at that point.
You don't.
But
no.
Yeah.
As long as it's I haven't found it to be an issue.
Yeah.
But yeah, the few times that we've run manual jobs with the pneumatic vices, the operators have been like, "This is great.
It's such a pleasure."
Yeah.
Yeah, it's pretty amazing.
It's notably faster.
Yeah.
Because you literally just open the door,
pick it up,
grab it. It's already loose.
Right.
Put the new blank in, and
hit
then
go.
Close the door and hit go, and it's like, that's it.
I know. It's only when doing that I have like looked at the doors and been like,
yeah,
I wish these were like lighter or easier to open, like
or automatic.
Because it's most of the effort is opening and closing that door.
Yeah. And then you really want to have like super dialed station where like you're like picking blanks from one side with one hand and like taking them out to the other side with the other hands. And if you had an auto, wow, you could be so fast.
Yeah. Interesting. I guess an auto door could make sense if you start doing a lot of that work. There's some very simple designs out there.
Yeah. I mean, if you didn't have to open the door, then you can literally have a blank in one hand and a finished part in the other hand at the same time. And so you could almost double your speed probably and have your number of like human. Yeah. Cause usually now it's like open the door,
right?
Loosen the vise, pull out, put on the table, grab a different part, put on the table. Cause often you have like a wrench in the other hand, or if you don't have the wrench in the other hand, you had to take a moment to put the wrench down on something.
Right.
Anyway.
There's a saying that time is the shadow of motion. So like these things do really add up and make a difference.
Yeah.
Third analysis, if you do the whole thing, it's basically like, I forget how many, 18 symbols, 28 symbols of like transport your hand empty. Yeah. Find with your eyes, grasp, lift, transport your hand loaded. Place. Yeah. And you see that whole list of moves, and like what you just described slashes, I don't know, 80%.
Yeah.
Right.
It's a lot.
Yeah.
According to people in the know, like the fastest way to process machined parts is just like simple 3-axis machines with a operator parked there and auto doors and auto vices.
Interesting.
Yeah. Or maybe not the fastest. Probably it'd be faster with a pallet changing machine. Mm-hmm. But when you take probably square footage costs and stuff into account or something else, or machine costs. I don't know. I just know that there's a lot of factories in other countries with compact, simple, like robo-drills and speedios.
Yeah.
Just one next to the other for miles with a person in front of each one, just swapping parts. Yeah.
I feel like that might not be super applicable to the US. Like, I wonder if that's reliant on inexpensive labor.
100%.
Yeah.
100%.
But it's fast.
But it's fast.
Yeah.
I think that's the key point here, is that it's fast.
Gotcha. Yeah. Interesting. Nice. We had, let's see, we ordered paper sleeves. Very exciting. The 3-ring binder plastic sleeves for a sheet of paper.
Yeah.
We've sort of been talking about different things we should do.
I went straight to flower bouquets.
Oh, yeah, that could, yeah. And just ordered some of those because now we can handwrite notes and just protect them so they don't get soggy. And it's basically to avoid having to use a computer to make SOPs at like V1, you know, when you're like, this needs an SOP.
Yeah.
It's so fast to like grab a Sharpie and a sheet of paper, write out the basic SOP, put it in a sleeve, park it at the machine. You have an SOP. Yeah. And then you have somewhere to start, like going over to the computer, finding the right file, naming it the right name.
Yeah. It's just
I don't know. It's just there. It's done. It's V1 and it's So that I also wanted I want a binder next to the CNC of all the M codes and G codes, because I feel like when I'm
that's in the machine, right?
I do know, and that's what I always click through to reference. But if I'm running through a program, like the other day I was reviewing the tool break detect program to see how it's passing variables so that we can start measuring the gripper fingers. I know someone wrote one with an offset for like face mills and stuff, so I need to basically implement that. Yeah. But I was also thinking about just doing a tool break detect. Oh, someone fat fingered the tool length offset. Oh. Because we change it every time, basically. Which the best would be to standardize, so you never have to change it. But as we've discussed on here, that presents a risk of like if you need to have it different, and now it's not part of the habit of like when you load a tool, you always change the offset. Right. Anyway, so I was looking through that, and so now you're clicking through the edit the program page, and then you're jumping into the G code page, and it's just it's annoying. So I just feel like if I just printed them out and parked them next to the machine, it's something I would reference.
I mean, there's also
similarly like all of our mapping for like the IO board at the machine. It's all in the computer, and I can find it, but it's like I just should have that in a binder. Yeah. So I think that will help just reduce the effort of going from nothing to something. Yeah.
You have a whiteboard on the machine, right?
Right. Yeah. Right next to it. Yeah.
I mean, we just put the commonly used M codes.
Same.
And up there.
Yeah.
Seems like good intermediate.
Yep. Yeah. Maybe that's V0 to V1.
Yeah.
I want V1 to V1.1. Yeah. Cool. And then lastly, we had an issue with making a whole bunch of pins that were only machined on one end because the stock was cut too short. So luckily it was in stainless and not in titanium, so the cost was really negligible, and it was a good learning experience for Sam, who didn't realize that totally understandable. I didn't train him well. There was no clear documentation on how to do it. And so he did it. It was also fun because he was like, I'm just going to bang these all out, which is like this is again, like, I feel like everyone's taught that that's like a go-getter attitude, right? Like, let's just get it done. And it's like, well, now we made a lot of these that just are scrap instead of just making the ones we need for today and then making sure they work and then going back. So good learning in a bunch of directions, and not at a high cost. So that was great. Haven't really improved that yet, but it's just an issue we had. So we're trying to figure out what our approach will be.
I think even just like having flagged it is an improvement in and of itself.
Definitely. I think this is maybe what separates organizational learning from individual learning is like whether that gets documented so that the next person who joins the shop is aware of it or that it actually never happens again, or if it's like, oh yeah, they're new. Yeah, they made we've all been there and made that mistake. That's sort of like a failure of documentation and SOPs. But
absolutely.
Yeah, that's all I got.
Cool. That's all I got. We'll wrap it up right there for the episode. Thank you all for listening. You can find me on Instagram at lichen_MFG. And
you can find me at austere_manufacturing and the podcast at incremental CI. Till next week.
Talk to you soon.